Hi, this is Halal. In this video on Mathematical Economics series, we will solve a numerical on the applications of logarithmic differentiation in economics. So the question is, given demand function p is equal to 12.5 e to the power minus 0.005 q, find price and quantity that will maximize total revenue. So where p is the price and q is the quantity. Now first of all, we have to find the total revenue. Now the revenue that will maximize the price and quantity will be at that point where the marginal revenue is equal to 0. So first of all, we will find total revenue, and from total revenue we will find the marginal revenue. So the total revenue is given as, that is equal to price into quantity is the total revenue. Now the price is given as 12.5 e to the power minus 0.005 q times the quantity. So time is quantity. Now this is our total revenue function. From this total revenue function we will find the marginal revenue. That we know the marginal revenue is the first derivative of this total revenue function. So I will write d or our d. So that means we are differentiating this total revenue function with respect to quantity. That will give us the marginal revenue function. So this is equal to, now here there are two functions, this function which is in the brackets and this q. Now to differentiate this type of where we are given the two functions, we will use the product rule. The product rule says we write the first function multiplying by the derivative of second function, plus we write the second function and multiply it by the derivative of first function. So we will write this. So I will write the first function, that is so I will write here it is 12.5 e to the power minus 0.005 q, and take the derivative of second function, that is this q. The derivative of q is 1, plus I will write the second function, that is q, and take the derivative of the first function. Now the first function, the derivative of this function will be, now this is 12.5, now e to the power minus 0.005. now the derivative of this function is the ordinal function multiplied by the exponent. Now the ordinal function is e to the power minus 0.005 q multiplied by the exponent. Now the exponent is minus 0.005 q. So again I repeat, if we are given e to the power minus 3x, and if we are supposed to find the derivative of this function, so the derivative of this function will be, let us say this is equal to y is equal to e to the power 3x. That means dy by dx is equal to, now this is equal to e to the power minus 3x times the exponent, that is minus 3x. So this is the as we have seen in the earlier videos how to differentiate an exponential function. There I have explained it quite clearly. So this comes from this. We write this the first function, we write the given ordinal function and multiply it with the exponent. So I have just used that rule here. Now this will become, we will factor out this 12.5 e to the power minus 0.005 q. So I will write 12.5 e to the power minus 0.005 q. Now here remains this 1 minus this 0.005 q. Now as I have told you that total revenue is maximized when the marginal revenue is equal to 0. So we will set this marginal revenue is equal to 0. Now MR equals 0 implies this whole thing is equal to 0. So I will write 12.5 e to the power minus 0.005 q, 1 minus 0.005 q is equal to 0. Now solving this will become 1 minus 0.005 q. Now here it is in multiplication. When transposing, this will become the division. Now 0 divided by this whole thing is equal to 0. Anything divided by 0 is equal to 0, so this will become 0. Now again solving this will become 0.005 q is equal to 1, or q is equal to 1 hour 0.005, or q is equal to, now this is 5 hour 1000. So when reciprocating this will become 1000 hour 5, so this will become 200 when solving. So our equilibrium quantity is 200. Now to find the equilibrium price, we will put the value of this q in the price function. Therefore p is equal to 12.5 e to the power minus 0.005 q, or in place of q I will write this 200, that is 200. That will be 12.5 e to the power. Now this whole minus 0.005, this is 5 divided by 1000, so I will write minus 5 hour 100,000 times 200. Now cancelling 200 with this 1000, sorry, this is here 1000, so this will become 200 ones are 200 fives are, and 5 and 5 will cancel each other, so this will become e raised power minus 1. So I will write this 12.5 e raised power minus 1, which is equal to 12 hour e. Now the value of this e is, as we know from the earlier video, that is equal to 2.71 and so on, because it is an irrational number. Now when solving this will get to equal to 4.6. So the equilibrium price is 4.6 and the equilibrium quantity is 200. Now